Trying to get the last few people in here. Okay. Let me do this. I'll go to settings. This one. Turn it on. Okay. All right. And let me do a page here. Okay. Let's put you here for now. All right, I think we're ready to rock and roll. Okay, no real announcements, gentlemen. We're in the home stretch. I'm under the impression that we have 4 sessions remaining today, Wednesday, next Monday, and then next Wednesday. I'm under the impression that next Wednesday is our last session. So we'll focus on a chapter a day to review in preparation for the final. So today we're going to focus on chapter 1. As usual, if you have questions, feel free to unmute yourself to get my attention and we can talk about it. You can ask questions about anything that's on Pearson, exams, quizzes, or homework, right? So if you're stuck on something, just bring it to my attention and we can talk about it. So I guess I'll make this available. I don't see why not. Okay, so I went on and just made this chapter 1 final exam review. I just went on and made it available. I wish I had them for the other chapters ready to go, but I don't see them. I've had to make them, which is not a big deal. It's just time consuming. The main thing is I need to get it into my main folder, but it doesn't matter. Okay. So I think the final exam is scheduled to become available on May 5th and it's due on May 10th, right? I think not this Sunday, but the next Sunday. I think that's when that is. Okay, let's change the view to this. And also that May 10th, that Friday, May 10th at 11:59 p.m., that's the hard deadline for all assignments. So right now, you should be able to access everything that we've done in the semester. There's only a 5% late penalty, so you can still earn up to 95% on any assignment, including exams. We get unlimited attempts. The system is set to take your highest score. So what that means is that honestly, right now, any student can still get whatever grade they want. If you want an A, then obviously you need to get at least, at a minimum, get your exams up to an A. Let me see. Let me just update my attendance. Okay. Yeah. So let's take a look at chapter review. Okay. And let me see, 135. It should be right. Let's see. Okay. Let's start off with question 114. So this is just for practice. Let's go to question 114. Okay, so this comes from section 1.7, question 46 from the back of that section. If we consider this function, we're asked to find the derivative using the quotient rule and the extended power rule. All right, I think I'm gonna take some notes on this one and I'm gonna do it a little bit different. Mm-hmm. I'm gonna copy and delete this person in. A lot of moving parts going on over here. We're gonna hop. Actually, it's too late. Let's see if this works with this. All right. Charging my pen. Let me check the battery on this thing. I'm pretty sure it's low. Oh, this. So what I'm trying to do either. Pretty good charge. So we're gonna start here. Yeah, then also it's Monday, so like on the weekends I'm doing other things, and then I don't think about this until time for class to start. So if I have any kind of foresight, I try to charge things, but okay. So let's see. We're gonna start. We're just taking a derivative, right? So we have 7 plus x to the power of 7 under x squared, and this is our f of x. Now the x is the quotient rule. The quotient rule is what? Low d high minus high d low over low low. I am tempted to rewrite this. So I'm going to rewrite it in the following way. 7 plus x to the power of negative 7. So then this way, I don't know if this is any easier or not. But yeah, I'm just going to try this. So let's try this one first. So in this form, we will use the product rule, which is the first times the derivative of the second plus the second times the derivative of the first. So the first is this guy. The derivative of the second, the negative 7 comes down. We subtract 1. And the derivative of the inside, like it's 1. So the first times the derivative of second plus the second, which is this guy, times the derivative of the first is 2x. It looks like we can factor out that 7 plus x is a negative 7 from both, and also an x. So it looks like they both have this guy. They both have at least one x. And then what's going to be left over, in the first one, it looks like we have, okay, one of these guys persists. This persists. And the second one, it looks like we have just 2 remaining. Okay. Like I'm missing something. That's going to be 7 to the 8. I could distribute this. Let me see. Let me kind of go a little further. Now it's just a matter of just trying to simplify it. We got this on bottom, this on top. Let's see. If I multiply by 1, 7 plus x, 7 plus x. Okay. Let me see. That's going to be what? 14 plus 2x. So it looks like it's going to be 14 minus 2x over 7 plus x. Okay. Now we could combine this into one expression. Let's do that. If we combine this into one, on top we distribute that x, so we're going to get 14x minus 2x squared. Now we still got a 2x there. Looks like we can factor out, but I would only factor it if it canceled. And then if we multiply the denominator, it looks like we have 7 plus x to the power of 8. Now, if we factor out a 2, does that help us? That doesn't help us. This is as far as we're able to get it. So before I submit this, I want to compare. I'm going to compare it to the way that to the example. just to try to minimize the back and forth. So what I'm gonna do is view an example. And I just want to see that first part. That's fine. Okay, I think things should count. I'll get this student in just a minute. Okay, let's see. Still 10 parts. Okay, that looks similar to what we have, so that makes me confident. Yeah, let's just go what we have. I think what we have might be okay. Okay, let me see. So then, let's get rid of this. Come on. Okay. All right. So for our numerator, we have 14x minus 2x squared. The denominator, parentheses, 7 plus x to the power of 8. Okay, let's see if that works. Let's see, what do we probably got an error somewhere. Over 7 plus x. Okay, let's check over here. I'll let the student in. I feel like it's something small. Let's see what we got. All right, let's just kind of comb through it real quick. All right, let's see. Let's go with this color. So we got x squared, yep, to the power of 7. That's the same as that. So if we do product rule first times the derivative of the second, the negative 7 comes down. That becomes a negative 8. The derivative of the inside is 1. Plus the second times the derivative of the first is just 2x. Okay, so that looks okay. So I feel good about this one. Let's go to the next one. Okay. 7 plus x, that's a negative 7x. Okay, we factored out the 7 plus x to the negative 7. Let me think. Did I do that right? Well, maybe that's where I made my mistake. No, I think that's okay. Yeah, if we add, we get that. Okay, that looks good. We factored out an x, so there's a 2 left over there, and there is a negative 7x left there. I feel okay about this one, this line. So then 7 plus x, that's 14 plus 2x. So that's mine. Oh, there it is. I see the mistake. So 14 plus 2x is going to give us what? 14 minus 5x. And we put minus 2x right here. This is supposed to be a 5x. Okay. If that's 5x, that makes this a 5x squared. And I think everything else is okay. Okay. That seems feasible. So instead of a 2, it looks like that's supposed to be a 5. Okay. All right. I think we're good now. Okay. So that was the first part. Using the quotient rule, and note that f of x equals it. Oh, well, that's the way we did it the first time. So it's going to give us the same answer. I'm going to say 14x minus 5x squared. 7 plus x to the power of 8. Okay. Yeah, they're the same. Okay, that's fine. Let's just do another random one. Let's go to question 76. Everybody. Find the derivative. Okay. Oh, there it is right there. Okay. So this is question. This is question 76. This comes from section 1.5, question 46. find, I'm just going to say find y prime, just we're finding the derivative. We got 3x to the power of a negative 5 halves plus 8x to the negative 1 half plus x. This one looks fairly straightforward. Let's see. I mean, you never know until you go to try it, and sometimes they do the cookie. But it looks like just a power rule, right? So y prime, the power comes down. Looks like it's going to be a negative 15 over 2. X to the power of a negative 7 over 2. So we brought the power down and multiplied those coefficients, and then we subtracted 1 from the power. Same thing with the next one. So that's going to be a negative 4x to the negative 3 halves, 10x to the power of 9. And then the derivative of a constant is 0. I think we can submit it just like this. So we got a negative 15 over 2, x to the power of negative 7 over 2. Okay. Minus 4x to the power of negative 3 halves. Plus 10x to the power of 9. Okay. All right. So let's generate another random. Let's go to question 84. It says the median weight of a boy whose age is between 0 and 36 months can be approximated by this function where t measures in months, t is measured in months and w is measured in pounds. Use this approximation to find the following for a boy with medium weight in parts A through C below. The rate of change of the weight with respect to time. So basically they're asking us to find the derivative. I think I might be able to do it here. Yeah, I should be able to. So for instance, if we're taking the derivative of that function, the first term, the derivative of constant is 0. Then the next one looks like it's just going to be 1.97. 1.97. 2 times whatever that number is. So minus. Siri, what's 0.0067 times 2?
0.0067 times 2 is 0.0134.
T. What is that, 63? So we're going to say plus 000 63. No, that's not right. Siri, what's 0.000219 times
219 times 3 is 657.
657. Okay. T to the power of 2. So, that one was more so, like, I mean, you know how to take the derivative. That one was more of a calculator problem. The weight of the baby at age 14 months. So then we plug 14 into the original. I just don't feel like doing it. All right, let's do this. Put this over to the side, actually. Open it up first. Right here. So I think I'm just gonna straight use the calculator for this one. If I go to my y equals, let's see if I can power this on. Okay. If I go to my y equals, we got 8.69 plus 1.97x minus 0067 x squared plus 0.00219 x to the power of 3. Okay, so then if that's our function, we want to evaluate that function when x is 14. Two decimal places would be 56, 35, 50 pounds, 35.56. Let's see the last one. The rate of change with respect to the time at 14 months. So I think we can just do that in the calculator as well. If I go to like math, derivative is number 8. I want to evaluate that function we just typed in and with respect to x when x is 14. I think that's it. Okay. Two decimal places. So 1.91 pounds per month. So it's growing at a rate of 1.91 pounds per month. Okay. Let's see if I can get this student. Sorry, guys. I think that like mentally I'm already on vacation, so like I am like totally checked out. I'm just trying to, finish and like try to get as many of you guys to this as possible. But my energy is shot. Like I'm like floating. That's what I feel like. 5'9", 59. And like I don't know if you I don't know if you guys are seniors or not. But there is a thing called senioritis, and I definitely experience it like as the professor literally every semester. Closer we get to finals, I just be like checked out. I'm like, okay, I'm done. Especially once we stop the new content. Graph this function. So we have a reciprocal function. Let me see. When x is negative, y should be negative, so it has to be d, right? It was a toss up between c and d, so then I chose a point. If x is negative, then y is also going to be negative. So the only one that behaves like that is d. So I'm just going to choose d. I think the first two are parabolas. Draw the tangent lines to the graph when the x coordinates are 0 and 2. When x is 0, I think there is no tangent line. When x is 2, well, the only one that has the right graph is C, because the other ones, the graphs are wrong. So I'm just going to go with C just because it has the right graph. Find f prime of 0 and f prime of 2. Okay. The slope of the tangent line. So when x is 0, it looks like, if I'm using that map properly, it looks like 8. When x is 0, it looks like the derivative is a positive 8. Let me just try positive 8. I'm just using a graph. Oh, wait. Sorry. They want the function. Let's see. Okay, so we're going to actually have to. Cool. Stop tantrum. So I think, well, I mean, we can do the quotient rule. So low D high minus high D low. So the bottom times the derivative of the top is 0 minus, so let me do my fraction. The top times the derivative of the bottom, so that's just going to be a -8 over the bottom squared, which is x squared. This should be it. You can do the quotient rule, or you can rewrite it where the base has a negative exponent, and then just use the product rule like we did in the other example. So now, when f prime is 0, there's no solution. Let me see. Yeah. Should be undefined when x is 0. And then when x is 2, let's see. So -2. I just plugged 2 into the first derivative for that part. If we look at the graph, it's kind of being temperamental. I might just bypass that. Yeah, I feel like it's hard to see. Okay. Well, anyway, we just plug it into the derivative for that part. Let's generate. Let's go to question 26. Determine whether the function is continuous over this interval. Yeah, I don't see any holes or gaps or breaks. So is it continuous from -6 to 6? We would say yeah. No holes or gaps or breaks, so we would say yeah. Oh, that was it? Okay. Let's go to random. Let's go to question 106. Okay, so to differentiate this, we have to use the chain rule. Right? I'm going to try to take my notes here. If I need to write it out, I can. So we have the square root of this expression is going to be the same as that expression to the power of a half. So then the 1/2 is going to come down. Okay. And then times the inside part, which is x squared. No. X squared plus 9. Then it's going to be to the power of a -1/2. It's not a 1/2. Okay. Times the derivative of the inside part. So the derivative of the inside is just going to be 2x, and then we do kind of need to simplify this. It looks like the 2's are going to cancel. You have a 2 on top and a 2 on bottom that are going to cancel. So then it looks like we're left with an x on top, and then the square root of x squared minus plus 9 on bottom. That's it. Oh no. Are you sure you want to continue without? No. Okay. I keep accidentally clicking places I don't intend to click. Okay, I think this looks okay. Okay. All right. Let's generate. Let's go to question 93. Okay. So quotient rule, bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, it could be B. I was gonna say it can't be B, but sometimes things cancel. I think the best thing is that we probably write it out. Let's just write it out. Cut corners, or try to cut corners. Let's see. So I'm gonna go like this. Now that's fine. This is question 93. This comes from section 1.6, question 23, okay? I'm just gonna say differentiate, abbreviate it. On top, we have 4x squared minus 9, 5x cubed plus 2, and y equals, okay? So then if we're gonna do the quotient rule, it's gonna be the bottom, which is this guy. The derivative of the top looks like 8x. So the bottom times the derivative of the top minus the top, which is this guy. Derivative of the bottom looks like it's what, 15x squared? All over the bottom squared. And can we get anything to factor and cancel? We would need a 5x squared plus 2 in both. We might be able to take this further. I'm going to see if this is one of the results. If this is one of them, it could be either A or D. 5x. Oh, wait a minute. Which of the following shows how to find the first derivative? Okay. 5x cubed plus, so the first times the derivative of the second. The bottom times the derivative of the top. Minus the top. Yeah, that looks good for A, right? What's the difference between A and D? I think they got the order wrong in D. So we're gonna go with A. Let's see if they want anything else. Can we take this further? Let me see. Now what we could do is expand it. Now since we're working in this device, I'm just gonna click on a they don't have it. Okay. I was gonna try to do an example. Let me see. Let me just look at it real quick. I think I'm avoiding trying to expand this out. I think I'm just gonna submit it as is. All right, let's just try it. If it doesn't work, then we'll try to take it further. Because sometimes they take it like that, and it's okay. You get on an exam, you can challenge it. Just challenge these, like on the final. If you feel like you want to challenge a result, just notify me ASAP so that I can look at it and we can investigate. Okay, so let's go to parentheses. 5x cubed plus 2. Sometimes they take this and sometimes they don't. 8x. I figured instead of racking our brain, 4x squared, trying to expand this guy. Minus 9 times 15x squared. Okay. And then 5x cubed plus 2, parentheses. Oh. 5x cubed plus 2, quantity squared. Can you please go over? Let's see what happens. Nice. Okay, so let's do another one. Let's go to question. Hang on, I'm gonna suppress this because that's distracting. Close settings. I think we got most people. We'll go to question 14. Let me see. A courier services rates are 37 cents for the first ounce and 23 cents for each additional ounce or fraction thereof. If X represents the weight of the letter in ounces, then P of X is the cost of sending the letter, as shown on the right, up to 13 ounces. At what point does cost also depend on? At which point postage cost also depends on distance. Using the graph of the postage function, find the following limit if it exists. The limit of X approaches 3 of this function. So as X approaches 3, it looks like our P of X is 83, right? So as we approach 3, now if it wants to limit, it wants the amount on the left and the right. Now, the limit as X approaches 3 from the left is 83 cents, but then from the right, it's something else that we are not sure of. So we would say because the left-hand limit does not equal the right-hand limit, we say the limit does not exist. It should be the limit does not exist. All right, because the left-hand limit does not equal to the right-hand limit. Okay. All right, let's see what else we got. Generate. Let's go to question 84. Yeah, 84. Oh, that's interesting. Let's go to question 85. In T years, the population of a certain city grows from 200,000 to a size P given by this guy. Find the growth rate. So basically the derivative, like it's going to be what? 6,000 T? $6,000T. Find the population after 15 years. Siri, what's 15 times 15 times 3,000 plus 200,000?
15 times 3,000 plus 200,000 is 875,000.
Okay. The growth rate after 15 years, so 15 times 6,000. Siri, what's 15 times 6,000?
15 times 6,000 is 90,000.
Okay. What is the meaning of the answer in part C? So after 15 years, the population is going to be growing by 90,000 people per year. It's going to be growing at a rate of 90,000 people per year. The growth rate tells the rate at which the population is growing after 15 years. Yeah, let's go with C. Okay, let's generate. Let's go to question 122. Okay. So this is the second derivative. The second derivative of y with respect to x. The first derivative, I guess I need to write this one out. Let me just write it right here. So this is question 122. This comes from section 1.8, question 11. We're asked to find the second derivative of y with respect to x. Okay. We're given y equals the square root of x. So then dy by dx, 1/2 comes down as x to the negative 1/2. Then the second derivative of y with respect to x. So the 1/2 comes down again. We get a negative 1/4 x to the negative 3/2. I think that's it. We should be able to go with this. Okay, let's try this result. Yeah, I think it's because I'm looking down. Like, I hadn't been sleepy or yawned all day, but I think also early, I took a nap and everything. I don't know. Negative 1/4, 1/4, x to the power of a negative 3/2. That should be okay. Okay. Generate. Let's go to question 117. That's 24, 21, 20, 19, 18 right here. Nice. Given the total revenue function and total cost function, both in thousands of dollars, find the rate at which the total profit is changing when X items have been produced and sold. So basically, we find the profit, which is going to be revenue minus cost, and then we take the derivative. And still don't feel like going. What time is it? Okay, we don't have that much time. We'll hang out for like another 20 minutes. Yeah, like all my classes are wrapping up. My other class, today is their last set of new material. Another group I'm with, tomorrow's our last time being live. Like, yeah, everything is wrapping up. So, okay, sorry. Let me see. So this is question 117. This comes from section 1.7, question 61. Looks like it's business economics. Okay. Now, revenue function, 1100 times the square root of x squared minus 0.1x. Okay. Our cost function, 1600 x squared plus 5 to the power of a third plus 800. Okay. They want p prime. All right, so profit. So what we're going to do, the game plan is we find our profit function, which is going to be revenue minus cost, and then take the derivative of that guy, and that should be it. So a profit should be the revenue minus the cost. 1100 square root of x squared minus 0.1x minus the 1600. Now we got to be careful here. X squared plus 5 to the 1/3. We got to say minus 800. That should be fine for now. So then we're going to do p prime. See, the 1/2 comes down, so I think that's 5,500. Sorry, 550. Let me see. X squared minus 0.1x to the power of a negative 1/2 times 2x minus 0.1. So, okay, so we did the derivative of the outside function times the derivative of the inside function. Now the 1/3 comes down. So that's 5, 3, 3, 3 bar, something like that. Times x squared plus 5 to the negative 4/3 times 2x. So again, it's really the chain rule several times. I think I'm going to submit it like this. That 533 1/3. I might leave it as 1600 over 2 and over 3. Okay, let's see. So 550 parentheses x squared minus 0.1x, x squared minus 0.1x, okay, to the power negative 1/2, okay, times another set of parentheses, 2x minus 0.1, 2x minus 0.1, okay, and then minus, I think we agree, let's leave it at 1600 over 3. Mm-hmm. 1600 over 3. Okay. Wait a minute. $32. Let's put 3,200 here. They might. I think we're okay. Yeah, let's keep going. 3,200. There's an X here, and then it looks like we have that parentheses. X squared plus 5 to the power of a negative 4/3. Okay, that's about the best we can do. Cross our fingers. All right. Let's see. Where could we have made a mistake? Now that was 1600 over 3. Siri, what's 2/3 of 1600?
2 over 3 times 1,600 is approximately 1,066.6666.
Yeah, these numbers are fine. X squared plus 5, negative 4/3, 2x minus 0.1. Oh, we could probably combine those. That might be what needs to happen. Find the rate. Let me see if I can view an example. Yep. 11 parts. Let me see. Chain rule, yeah, we did all that. So they basically found the derivative of each part. Now, let me see. Yeah, that minus that over that. Maybe it's the form that we have it in. Maybe. And like we might need to combine those guys. We combine that 550. Yeah, it looks like we need to distribute that 550. Let me see what their final one looks like. Okay. Because we got that part down there. We got the X up there. So we kind of combine those. And we just need to distribute. Okay, I'm gonna try to get it to match theirs. Okay. As far as the form. I think that's what's kind of throwing us off. So then, let me see. 550 times 2 is 1100. So we need a fraction. We got 1100x right there. Okay. That's on bottom. So move the decimal to the left by 1. Should be minus 55. Now on bottom, looks like we have the square root. X squared minus 0.1x. Okay. That's about the best I can do there. Minus, let me see. The 1/3 came down times 2x. So 2/3. Two-thirds is 1600. So we can say 3200 over 3. Let me think. 3200 over 3. Okay. Okay, let's try that. So we got 3200x. Okay. And then we got 3. In the root. Okay. So we got a cube root of, what is this, x squared plus 5? All of this to the power of 4. Okay. Okay. So that gives us our negative 4/3. Our 2 is up there. Our x is there. All right. So we just changed the form to match theirs. We didn't really change anything. This might be okay. Let's just give it a go. Okay. We might get this one wrong. Let me check one more time. So 1100x squared minus 0.1x, 1600x squared plus 5 to the power of a third, right? Plus 800. Revenue minus costs. So we said the 1100x squared minus 0.1x minus the 16x squared plus 5 to the third. And it should be minus 800, but when you take the derivative, that term is gone. So now we take the derivative. The 1/2 comes down, right? We get 550 x squared minus 0.1x to the negative 1/2 times 2x minus 0.1. Okay. 1/3 comes down to, okay, let me see, x squared plus 5 times 2x. That looks good. So let's see. 2 times that is 1100, so that should be 1100x minus 55. That looks okay. Over x squared. Let me see, the square root of x squared minus 0.1x. Okay. That looks okay. Minus, let me see, maybe that's where we're making our mistake. 2/3. 32 over 3. Yeah. Minus 2x squared plus 5. Cube root of that to the power of 4? Yeah, I'm not sure. 5x. Is there an x up there? There is an x. Squared plus 5. And the derivative of a constant is 0. Let me see right there. 2x minus 0.1. Yeah, I got that. Yeah, I'm not seeing it. That's what, a 5? Okay, I think I see something. Because that's a fourth root, we have a perfect power of 3 in there that we can pull out. Okay, maybe that's it. That's the last thing that we can try. So what would happen is one whole of these is going to be gone. So we can get rid of this, and we're going to pull out. So it's going to be 3 times x squared plus 5. Okay. So then that's going to give us, if we say 3 times that, that's going to give us 3x squared plus 15. Right? Because we had a whole perfect power of 3 inside that radical that we could factor out. Now I don't know if I can get this to simplify down. We could factor out a 3, but yeah, I'm just gonna go with this. Let's see. 32 2/3. Okay, so that's what we made a mistake there somehow. Let me see. Oh, you know what? Yeah, we definitely did the power wrong, right? It was to the power of a third. When we subtracted 1, we put a negative 4/3. It should have been a negative 2/3. Okay, well, that wasn't too bad. Let me at least highlight it here. I think I'm done. I mean, we can do a similar. I don't really want to do a similar. I'll hit similar in cases if it's the same. Let's just try it. This would be it because we weren't that far off. Again, we made one error here. Right here, I'm gonna just mark it. This guy. This is supposed to be a negative 2/3. I'm just gonna try an alternate real quick. Watching the clock. So like if I can't get it, then we'll call it a day. This is economics. It's the same thing. Revenue. Cost. Okay. So then the profit function. Minus this guy. So then our derivative. 1/2 comes down, so that becomes 500. The negative 1/2 times 2x minus 0.3. Okay. Then minus the 1/3 comes down. So I'm gonna leave it at 1600 over 3. To the negative 2/3, okay, times 2x. Maybe it'll accept this one, right? Because we had the thing wrong in the last one, so maybe it'll accept this. If this isn't it, then I'm just gonna let it go. So let's see, 500. I mean, okay, we could put it in the form like they had. Let's do it. Let's try to match their form. So if we distribute that 500, that becomes 1000x minus. Now let me see. A 10th would be 50. So 150. Okay. 150. The bottom looks like it's the square root. X squared minus 0.3x. Okay, that's the first guy. Minus 32. So it looks like it's 3,200. Did we get everything? 2x minus 0.3. Oh, wait a minute. Right there, the third came down. We're good. 2x. Okay, let's keep going. So let's just do a fraction. So we got 3,200x. 3. Okay, we want to do in root. We got a 3 here. We got x squared plus 3 squared. 2x. Okay. All right. So trying to account for that mistake we made in the previous, we got it this time. Okay. All right, gentlemen. So I want to say that you can access this. This is a chapter 1 review. I'll try to go ahead and get reviews for chapters 2, 3, and 4 ready to go. Yeah, I can't think of anything else. The final exam will become available a week from this Sunday. So we have 3 sessions remaining, so we'll pick a chapter for each day. And yeah, that's it. Okay, guys. This is a good time to get caught up. If you are going back and doing old assignments, get caught up. My recommendation is to prioritize your exams first. That's where you get the most bang for your buck, and prioritize your homework last. Okay. If there aren't any burning questions, we're going to go ahead and end the session here. From one beautiful mind to another. Enjoy the rest of your day. Take care, guys. Peace. Go ahead and make a copy of this available.